Hi guys, welcome to today's topic. We're going to cover frames and machines, and for today we'll start with frames. But before I even get to frames, I just want to go into a little bit of a review of what trusses are. So we said that trusses are made up of simple members, slender members, and what they do is that they're just basically two force members that are pinned together to form a structure. So you have a two force member, another two force member joined by a pin, another two force member joined by a pin. Through that, we can say that if there is a force applied at any of the joints, you should be able to find out what is going on inside these forces, or the forces that are representing the member. And we said also that trusses are two force members, which means they can only accept forces in the tension or compression directions, and that's it. They only accept those two kind of forces. Okay, a frame is slightly different from that. That it's basically similar to what truss looks like, but it is able to accept multi-forces. Okay, so multi-force means it's more than just these two. It can also have something else being applied to it in terms of like moment or some kind of rotation or any other forces. Now you should have gone through the material that I posted on Blackboard, but what we're going to do is just go through a quick example to kind of help you understand what's going on. So remember that frame is basically treated kind of like how a truss would be treated, except that it is a structure that has multi-force members and more than just two, which is what a truss is. Okay, so a truss will not be able to accept moment and other things going on in there. So what you want to do is that you want to draw a free body diagram of the whole structure, solve for external reactions, and then you start looking at the individual members to be able to solve for unknowns. Okay, so the problem that we have in front of us right now, I think it's one of the options that I posted on Black. I believe is one of second example. So we're going to draw a free body diagram, which I have right here in front of you. So if you look at the original drawing, you see that the frame itself is staying the same. We have members from A, B, C, D, E, and then also E connecting to B. And then we have a pin at A, a roller at E, and then a 20 kip force applied at point D. So everything is very similar to what we've done before. It's nothing crazy, okay? So what we're going to do is that we're going to find our reactions. And as I said many times, summing forces and summing moments can be done in any form or order that you want to do them, but just try to minimize the amount of work that you do for yourself. So if you're looking at this, what we can do is that we can sum moment about A or about E and quickly eliminate a few things going on. If we sum moment about E, which is very similar to what I did in the example, we have AX going about E in the counterclockwise direction times 4 feet minus 20 kips times 5 feet equals 0. So quickly we found that AX equals 25 kips. Summing forces in the Y direction, and I'm showing that Y is going up as I always do, nothing new. AY is equal to 20 kips, and that's the only other vertical force showing up over there. So then easily we can find some of forces in the X direction. EX is equal to AX, and that's equal to 25 kips. And as I've mentioned before, that tells me if I get a positive answer for all of them, it tells me that my initial directions that I drew things in AY, AX, EX are correct, and the magnitude stays the same. All right, so now that I've found all my reactions, I'm going to go ahead and replace them with the values that we have over there. So we know that AY is 20, EX is 25, and then AX is 25 kips. All right, so now the best thing to do, just like what we did for trusses, is we're going to break it down into members, okay? So we have member A, B, C. So we'll start with member ABC, which I'm going to go ahead and highlight in red right here. So we're going to break up. We start with ABC. So we have, for member ABC, starting with our reactions, which we found we have 20 25. Okay, and then if you look at C, because C is a pin, we have CX and then CY. The direction we're drawing these reactions doesn't matter, okay? And then if you look back up at BE, because this is a pin and that's a pin over here, you can see that's a 2-force member, which means we have FBE somewhere in the middle. FBE, okay? And our slope, or to be able to find the angle, we have 4 going up vertical, 5 across, which gives us a horizontal of 5.38. And if you look at the question, that's already given to you as well. So that's really nice. Okay, so I'm going to quickly go ahead and add our dimensions so that we don't get confused later. All right, so the next thing to do is just sum forces, sum moments. It's as simple as that. It's pretty easy to follow. Okay, so we have summing moment about point C, and with some moment about point C, that eliminates CX, CY, which is 2 unknowns and makes life much easier for us. So some moments about C, we have the 25 kips times 4 feet minus 20 times 10 feet plus FBE, okay, times the horizontal 5 over 5.38 times 2 feet plus FBE times 4 over 5.38 times 5 feet. And that's equal to 0. So that quickly gives me FBE as 26.9 kips. Okay, so that's one of my answers. And then summing forces in the x direction equals 0. We have negative 25 kips plus CX minus FBE times 5 over 5.38. And that gives me CX of 50 kips. And then sum forces in the y direction. I have 20 kips minus FBE, okay, this is going down, times 4 over 5.38 minus CY equals 0, and that gives me CY of 10 kips. Okay. So if we come back here, the question is asking us, determine the components of all forces acting on the member and ABC. So if you look over here, we have CY, okay, so if you go back to the main drawing, and I like to draw this out in yellow, just to kind of show all the potential forces. So we have CX, CY, we have just a roller, right, so we have E, some force E, we'll say EX, we have AX, AY, and then we have normally we would have BX and BY and EX and EY, but because that's a 2-force member, we're going to do FBE, and it's as simple as that. So we have FBE over here. So if you're answering the question, finding all the forces acting on member AB, we found AX, AY, FBE, CX, CY, and that's right here. I hope that really helps clarify things.